So in the first instance, why is it that buildings are a really critical part of this story? And this analysis from the IEA shows the importance that buildings account for in terms of energy, direct energy use globally, 36%, for which residential buildings are responsible for 22%, non-residential for 8%, and then the process of constructing buildings, another area where innovation and technology and smartness can be brought in to improve emissions. So when we look at the emissions, though, on residential buildings are approximately 17% overall, but much of that is indirect. And this is really where we're talking about the grid. And non-residential, again, being a large part of emissions coming from grid, 7% of there from indirect. And again, building construction as a key part of delivering an emissions reduction strategy. So the reason why we want to really focus in on the efficiency side is that we can reduce the amount of energy being used here. But then as we see in the emissions, that interaction with the grid is going to grow and become more and more important. So really being able to manage that and ensure that it is as interactive as possible to achieve the efficiencies as well as the emissions reduction alongside. The drivers of demand continue to change in that we know we need in many countries around the world, and certainly across the ASEAN, there's a growth in demand for housing, there's a growth in demand for buildings, and to continue to construct buildings in an efficient way is really critical here. So this figure really tracks across as we build more buildings and population continues to grow in some locations. The energy use is beginning to tilt downward. This is really important, and in particular, the emissions continue to tilt downward as well. So it's important that as we build buildings, that we're mindful that their performance is going to be constructed so that their lifespan, the 20 to 40 years that they may be with us or longer, that they're going to use energy most efficiently. And that can be done today using technologies that we have. In the first instance, the control that we have over development of buildings is in that initial design phase. And as our introduction noted, the ASEAN roadmap for building and construction towards net zero really supports those initiatives at the first instance of site design. So this is where we can really make first progress towards smarter buildings. So being able to focus then on the building design itself, ensuring that not only have we laid out the development area in a way that supports efficiency, but also then the building design really focuses on the materials, the windows, the ability to avoid or minimize heat gains, and then focusing on the passive systems such as natural ventilation, the use of daylighting, the use of cross ventilation where possible, and then being able to consider those mechanical systems, heating, cooling, fans, and lighting. And then we get into the area that we're talking about today, which is how it is that smart systems can support the efficiency of those mechanical systems, of the passive systems. But we really need for efficiency to be embedded first in that so that the smart systems can ensure that we have good occupancy sensing, daylight sensing, automated controls, and grid interactivity. And then finally, through all of that process, we have an opportunity to build in renewables that will support the demand on site of energy, but then also to feed back and become more active with the grid, whether that's solar PV or wind or the like. So when we see your roles or we see our own roles within this, this process, these tiers, there'll be the designer-oriented roles at the very outset, and they're really critical to shaping what it is that the more engineering-dominated roles have later on. I'm just going to very briefly touch through the first and then pause for a moment on the latter. So, what is it that we can do at the very outset? Well, landscaping and solar gains on buildings. So this is really understanding how the buildings themselves are sited. Thinking about that seasonal variation at the outset. Obviously, across the region in the ASEAN, there's considerable difference in terms of that environment, and being able to make use of those natural flows is really important. So whether that's wind patterns or orientation of buildings in terms of solar gains and the like. We can then think about how it is the building is constructed. So thinking through those uncontrolled aerial infiltration, the variation of the quality of the building, of the envelopes, moving from what might be very high dense materials, very heavyweight buildings, through to different opportunities of window and glazing, lightweight structures, better purpose for ventilation. And these types of design decisions that we make in the outset will affect how it is that we need to be able to heat, cool, light these buildings going forward. We also have an approach of moving historically from a very passive design through to what might have been the modern design, where there's a high degree of air handling units and heating and cooling units, a very mechanical building, now towards a sustainable opportunity where we can design buildings such that they are both passively designed, and when needed, we can make use of mechanical systems so that they're most efficient. So then we get into the mechanical, and as we increase the intelligence and flexibility of those systems, we can better ensure that comfort is being achieved when energy is most needed to be used. So active heating and cooling systems, fans and lighting can be placed alongside the available resources for passive means. And so what does that mean? It means making use of smart systems that are capable of doing that and supporting these. So for example, when looking at smart occupancy sensing in buildings, we're able to heat and cool that space or daylight that space so that it's comfortable when people are using it. And at other times, it's not essential to be able to achieve the really high standards, say for an internal temperature when it's not being occupied. So there's lots of really great examples across the region of buildings that are becoming much smarter around how it is that they deliver comfort in times when they're being occupied, but then being able to vary their controls when unoccupied. So having automated weather adjustments and comfort controls, and our speakers today are going to highlight some of these in terms of that really fine scale control that buildings might have within single office spaces or single dwellings, through to very large across an entire portfolio of buildings being able to control and adjust. And the last one being on-site renewables. And this is a real opportunity for us to integrate in the building renewables that support, for example, on-site generation, or being able to switch certain types of fuels, improve the grid resilience. And I think this is, again, something which Randy mentioned, the idea that that interconnection between buildings so that there is resilience going both ways. The building can act as a buffer and a mechanism to improve resilience of the grid, and likewise, the grid can become more resilient when it knows buildings are as efficient as possible so that they're not drawing big demands during periods when, for example, heat waves are being experienced. And it's also an opportunity for a more engaged building, as it were, to be a prosumer, to be able to sell the excess energy that may be generated from renewable sources into the grid. I wanted to take also a moment here to highlight some of the concepts that we have around zero carbon buildings. And in the first instance, it's critical that energy efficient buildings are that first step. And this figure that we have here showcases that transition from highly efficient buildings to those that are capable of becoming zero carbon. So a low carbon building should already be an efficient building, but then begins to increase the supply of renewable energy or low carbon energy. And then as the building is able to reduce its demand further, and more on-site available renewable energy can continue to offset that on-site demand, till we get to a point where we have a net zero carbon building, and that is where it is efficient and relies on renewable energy sources that really meet that demand over the course of a period, for example, a net zero annual. And lastly, zero carbon buildings, and this is where a building can meet all of its demand through on-site renewables or off-site renewables. And the last stage, which is really critical towards achieving our targets ultimately, is a whole life cycle net zero carbon building. And this is where both the building, in terms of its operations, are net zero, but also the emissions associated with their construction. This is a really critical part of those materials becoming lower carbon and zero carbon in time to support this. So I'm going to very briefly mention a few things to help set the scene around efficient operations of buildings. we know that as we see demand for end services increase, it's really critical that we're able to see that growth occur in a most efficient manner. So appliances, for example, and ownership of appliances across the region here in ASEAN, some analysis done with the IEA, looking at end uses by 2030, and really being able to note that we do expect there to be growth across residential and non-residential. And a lot of that is embedded in more efficient units so that they're able to curtail the amount of energy needed in the future, but not the amount of services being provided. This is really critical. We need to ensure that there are a greater increase in access to energy to support the quality of life. When we look at what sort of systems and operations we're thinking about, so a smart building is going to be one which is better able and better attuned to its occupants, whether that's smart lighting, whether that's smart security systems, smart energy management systems that are balancing everything from vehicle electrical charging through to daylighting and ventilation systems and the like. And then as we move through looking at indoor environmental quality, this is again a really important part of smart buildings and their operation for efficiency, is also thinking about when can the building really open up and breathe, to ensure that the air quality is well maintained. And then when it needs to be, filtering air and making sure that it's safer. And ultimately, being able to track the operation of the building ensures that the systems are working effectively, that the operation is being tracked and maintained. And that means that we can have a system that is a longer life overall. Very lastly, just to mention a few things around types of systems that we'd expect to see, appliances and lighting, smart devices, smart LEDs, smart meters, a lot of the application being focused in terms of air conditioning units and split systems. The efficiency that can be adopted into these different uses is going to improve over time. And then in non-residential, we have an opportunity to really think about much larger systems. And again, being able to balance the needs of what's going on in that space, for example, office work or factory work, to be able to make use of more efficient technologies. I'm just going to say a few last words before getting into the detail of grid interactive buildings and leaving it to our panel to explore that further. But when we look at the transition for net zero emission scenario that the IEA produced last year, we really want to highlight that behavior and avoided demand and efficiency and electrification are the key ways in which buildings are going to deliver through emissions reductions. So we see here that behavior and avoided demand, but energy efficiency coupled together with smart systems are going to be really critical for that. And so as we move from the current situation through to 2050, we need to adopt these systems that are able to support that. And as a part of the system that we're looking at, we're looking for the idea that we move from a more intense system, which has a lot of potential for improvement, through to these different technologies being adopted. So just in summary, as we go towards smart interactive buildings, the types of opportunities we see here are that they're efficiently designed, that they're able to adopt smart systems in their operation. They're going to become more interactive with two-way grid and the interaction with the utility grid to make better use of that demand of the building and opportunities of renewable generation. When we look at the different ways in which we can think of grid interactive buildings, we have the communication system within the building, we have the communication across all the different activities of the building, of the service demands of the building, and these are being optimized to deliver efficient, but also low cost in terms of time use pricing or other grid opportunities to reduce the burden of buildings on the grid, but also to make them more self-sufficient where it's sensible to do so. And as we move towards a more grid interactive system, we want to see efficiency embedded in all of those aspects, because as we know from that initial set out, as we reduce the demands, we can better make use of the opportunity for renewable energy to achieve on-site and zero carbon outcomes. So I'm going to stop there.